In April of 2016, a 7.8 magnitude earthquake struck off the coast of Japan. The quake was so strong that the seafloor was literally ripped apart, forming a huge crack over 180 miles long. It's pretty impressive, but hardly anything new. Quakes happen all the time. This one just happened to be particularly large. But here's where things get weird. The earthquake wasn't caused by tectonic plates colliding, but instead by a gigantic underwater landslide. As for what triggered that landslide, well, nobody really knows. So let's talk about the Pacific Plate, baby. So what exactly is going on down there? Deep under the ocean between North America and Asia lies the infamous Pacific Plate. It's a tectonic plate that spans almost half of the planet, covering over 41 million square miles, an area larger than the entirety of the United States. And this plate isn't just hanging out. It's on a journey across the Earth's surface, albeit a really slow one, moving at a rate of about 2 inches per year. The Pacific Plate has a reputation for being a bit of a bulldozer, shoving its way up against other plates, including the North American, Eurasian, Philippine, and Australian plates. Similarly, the Pacific Plate's run-in with the Philippine Plate gives us the stunning but occasionally volatile Mariana Islands. However, the real showstopper is the interaction between the Pacific Plate and the Australian Plate along the southern coast of New Zealand. Here, the Pacific Plate isn't just pushing, it's diving beneath the Australian Plate in a process known as subduction. This dive creates the notorious Hikurangi subduction zone, which stretches for over 620 miles. It's a significant geological feature and a potential troublemaker when it comes to tsunamis. In February 2023, a 7.2 magnitude earthquake struck near New Zealand's East Cape. Then there was the February 2016 event that saw a 7.8 magnitude quake hit just off the coast of New Zealand's southern island. The Pacific Plate is special because it dives deeper and farther than most. It's currently about 22 miles below the surface, a depth known as the Benioff zone after the geologist who discovered it in 1953. But here's the catch. The Pacific Plate isn't just diving straight down, it's actually taking a bit of a detour, sort of like a surfer taking a longboard ride on a wave. Instead of going directly under the Australian Plate, it's moving towards the northeast at a speed of roughly 3.3 inches per year. This unexpected twist has a lot of scientists scratching their heads, trying to figure out why the plate is taking a holiday from its usual path. What we do know is that this detour has some serious implications. It's creating a gap between the two plates that can reach depths of up to 12 miles. As the Pacific Plate continues its funky dance with the Australian Plate, it's pushing sediments and rocks over 2 miles deep into the trough. Some researchers suspect that these deep-sea landslides might be the true source of those giant earthquakes. For instance, scientists have analyzed the chemical composition of sediments collected from the sea floor, and what they found is that the sediments in the trough contain materials that are much younger than the surrounding areas. Researchers discovered that the seafloor in the trough is tilted at a sharp angle, about 4 degrees. It seems that the weight of the overriding Australian Plate is causing the seafloor to tilt downwards. And if that downward tilt gets too steep, it triggers a landslide. And when a landslide happens under the ocean, the result can be catastrophic. The massive movement of water can create giant waves, potentially leading to destructive tsunamis. In fact, the 7.8 magnitude earthquake in 2016 might have had its roots in one of these landslides. It looked like it was caused by a sudden downward slumping of the seafloor. If that's correct, it means that New Zealand is sitting on a powder keg, waiting for a big one to hit. If a massive landslide happens farther up the subduction zone, where the plates are closer to the surface, it could potentially generate a devastating tsunami. We don't really know how often these landslides occur. They could happen every few hundred years or every few thousand years. Scientists have studied ancient sediments and fossils in the region, and they've found evidence of past tsunamis. How do you convince folks that a tsunami might be on its way without causing a mass panic? It's a tough balancing act between preparing the public for a potential disaster and avoiding unnecessary alarm. Right now, scientists are focusing on understanding the basics of the system better. By studying the geology of the region, analyzing seafloor data and looking at past events, they hope to piece together the puzzle. In the meantime, New Zealanders are doing what they do best, enjoying life on a beautiful island nation while keeping an eye on the horizon. So there you have it. We may not have all the answers when it comes to the Pacific Plate, but one thing is certain: Mother Nature has a way of keeping us on our toes. And if you're enjoying this channel and want to keep learning, stay tuned for more fascinating science stories. Thanks for joining me on this journey through the world of plate tectonics and tsunamis. It's been an incredible ride. But now it's time to make your own journey through the comment section below. What did you find most surprising about the Pacific Plate and its potential for causing tsunamis? Did you know about the Hikurangi subduction zone before watching this video? And while you're down there, if you enjoyed this video, be sure to hit the like button. It helps us reach more curious minds like you. Thanks again for watching. Stay curious and we'll see you in the next video.